Okay guys, a car of mass m kilograms to travel along a level road. The resistance to the motion is now resistance to the motion. Okay, is mkv squared newtons. That's the unit, not actually in the equation. Where v is the speed the car is traveling at 14 meters per second. The engine cuts out. 10 seconds after the engine cuts out, the speed of the car is 7 meters per second. Show that k equals 1 over 140. So your acceleration is basically, we'll start off with force because that's what we're given, okay? Force is, it's a negative force because it's slowing you down, minus mkv squared. Force is ma, which is minus mkv squared. A, therefore, by that logic, when you cross off the m's, it's got to be minus kv squared. Okay? We got to check out what type of question we're looking for. Are we looking for a S or a T question? That's what we're trying to figure out here.
T question. Didn't get any better.
Okay. Phi is 14. Phi equals phi because we don't know anything about it. S equals 0. S, just call it S1 at the end. T equals 0, and T therefore equals 10.
Not put the second v as 7.
Oh, sorry. Yes, 7. V is 7. T equals 0, and by the end of it, it's T equals 10. So what we're going to do next is we've got to choose which A to work with. By the way the limits are setting up, we'd probably be looking to go with T. So we're going to say dv dt. Dv dt equals minus kv squared. Okay, then we're going to say that 1 over phi squared dv equals minus k dt. And then what we're next going to say then is that 1 over phi to the power minus 2 dv equals, what is it this time? Minus k dt. And then we're going to integrate both sides. Okay guys, so match them up. We're trying to figure out k, aren't we? So the fact that we have a full set of limits here means that we have no letters missing bar k. So that means we should be able to figure it out quite quickly. So we're going to get 14 and 0 on top. 14 and 0, let's say. And then on the bottom it's going to be 7 and 10. Okay guys, so what's going to happen here is we're going to integrate. We're going to get minus 1 over, we're going to get minus 1 phi to the power minus 1. And we're going to get 14 and 7. And then on the other side we're going to get minus kt. And that's from 0 to 10. And then we're going to get a minus, that's basically minus 1 over v. So we're going to get minus 1 over 14 minus 1 over 7. And that's going to be equal to minus k times 0 minus k times 10. And what I'm going to get is 10k equals 10k equals minus 1/14. Now remember, a 7th is 2/14, okay, or plus a 7th, and we're going to get 1 over 14 equals 10k. K equals 1 over 140. That's actually not too bad at all. Okay, and then show that the car travels a distance s meters in the first t seconds after the engine cuts out. Show that this s value is ln 140 ln 1 plus t over 10. Okay guys, so what we do is we're going to take our k value of 1 over 140. Okay, we're going to bring it back up the top. So we're going to move back to where we began, and now that's going to be minus 1 over 140 v squared, right? Is that right, is it? 1 over kv squared? Yeah. Okay guys, next thing is we're no longer going to be using the VDT because we have to find out distance, okay? So it's going to be phi times the VDS, or sorry, the in-between, sorry guys, the in-between stage is you do the chain rule, okay? And the STT is V, so it's going to be phi times the VDS. And that's all going to be equal to minus 1 over 140 v squared. Okay? And we're going to match up limits now, okay? Got it. Alright? The limits are the following, okay? Your velocity is what before it cuts out? 14, isn't it? T equals 0. T equals capital T at the end, and V, it travels at an S meters after the engine cuts out. So what does that mean about your velocity? What will your velocity have to be? 0. Okay, your velocity should be 0 for that to work out. When the car is traveling 40 minutes, the engine cuts out. 10 seconds after the engine cuts out, the speed of the car is 7 meters per second. The car travels the distance S meters in the first T seconds after the engine cuts out. Show that S equals ln 1 plus T over 10. Okay. So, there's a problem with this question here. The problem is we need to relate S to T and not... We need to relate S to T, and we're not relating V to T. So, I don't know. I actually don't know what V is. I have to actually go directly to S now, okay? So to go directly to S, what we're going to do is S is 0 when T equals 0, and S equals S, okay? Now, as it turns out, I'm first going to have to relate, I'm going to have to first relate S to V, and then I'm going to have to go through, so basically the combinations I can have is V and S or V and T. I can't have S and T together. So what I have to do first is I'll have to integrate V to VDS, and remember V is ds dt. That's the link. When I find out the answer for V, I can then relate ds to dt. So I have to go through V to VDS first, okay? So here's what we're going to do. We're starting off with this one here, okay? We're going to bring the V squared down, so we're going to get V over V squared dV equals 1 over 140 ds. We're going to have 1 over V dV equals minus 1 over 140 ds. We're going to integrate both sides. And what happens when we integrate both sides? I need my limits, okay? So it's going to be S on top, V on top, 0 on bottom, 14 on bottom. Integrate. When you integrate 1 over V, we're going to get ln V. ln V, V over 14 equals minus 1 over 140 S, and that's from S and 0. So what we're going to get is ln V minus ln 14 equals minus 1 over 140 S. Okay, ln V over 14 equals 1 over 140 S, and then change ln to log to the base e, same thing, and then isolate out phi by moving, so it's going to be phi over 14 equals e to the power of minus 1 over 140s. Bring the 14 up, phi equals 14 e to the minus 140 s. Now, here's the tricky part. Okay? Phi is ds dt. That's the definition of phi. And ds dt is 14 e to the minus 140 s. Okay? That e to the 140 s can be rewritten as 1 over e to the plus 140 s. Cross multiply, and we're going to get e to the 1 over 140 s ds equals 14 dt. I now need new limits, and the limits I'm looking for are up at the top. It's going to be capital T and capital S, capital T, and on the bottom I think they're both zeros. They're both zeros. Integrate again. Okay? The power never changes, so e to the power of 140s. When you differentiate that, yeah?
Where did you write the 14 first?
What happening next is you're going to get e to the power of 140 over s ds. Oh, sorry, and we have to integrate that, and it's going to be 140 at the front, because that'll, when you differentiate it, the 140 goes to the front, the 1 over 140 goes to the front, so that balances it out. And then that's going to be from 0 s to 0. The other one's going to be 14t, because you're like 0. Now,
14t.
Oh, 14t, you're right. And what's going to happen next is it's going to be a 140 e to the 1 over 140s. Okay, the next one is e to the power 0. When all of this is to the power 0, it's worth 1. So it's going to be minus 140. And then that's going to equal 14t. Divide both sides by 14, and we should get a 10 e to the 1 over 140s minus 140 equals t.
No, minus.
Sorry? Oh, 10. Okay. And what it wants me to do next is, I think it wants me to isolate s. So I'm going to go isolate s. Okay. So to isolate s, what we're going to do first is we're going to factorize out to 10. So when we factorize out to 10, we're going to get this. We're going to divide the t by 10. That gives us the t over 10 we're looking for. We're going to bring over the 1. That will give us the plus 1 we're looking for. Alright. Then we're going to have to ln both sides, aren't we? ln e to the 1 over 140s equals ln t over 10 plus 1. Then I'm going to bring the 140s using the power rule of logarithms to the front. T over 10 plus 1. Okay, ln e is 1. Bring up to 140, we're going to get s equals 140 ln t over 10 plus 1. That's that what I was looking for? Alright.